Hi, this is Sam Guan with Siemens PLM Software. Today I will show you the very last part of our design for manufacturing. In this case, we're going to apply this analysis to a particular assembly. We see that there are about 55 components within this assembly. Quickly take a look what all these components consist of. There are some covers, there's some housing, there's some fasteners and all that. There's some cover plates. So now, once again, inside the checkmate, we see that we want to create a particular test. So now we want to go in there and expand our design for manufacturing. We see that one of the options is for the assembly. Let's go ahead and execute that particular test. Now, this particular test does take a little bit longer if you consider there are 55 components, and each one of those components consists of many different features. The checks that we're going to take place is going to understand every one of those features, how it interfere or potential interfere with one another, or possibly alignment issues. So it usually takes quite a bit of long time. So in this case, I've already expedited the checks, and now we'll go ahead and we'll get the result fairly quickly. So now that once that is done, we'll go ahead and analyze what some of the results that we have seen. Let's take a look. The first one is what we call the hole alignment. When these assembly constraints are applied, they are properly applied between the geometry, whether it be faces or edges. But a lot of times that detailed features of these holes might not be properly aligned, but we'll never know because it's underneath. So in this case, we do see that there's potentially some misalignment of these hole features between the cover and basically the housing, or one of the in-between plates, if you will. So let's take a look at using a section view, see if we can get a better look at what that looks like. So let's go ahead and execute this particular section view. We want to see that in a particular direction, and using the manipulator we can quickly get our design and then stop at a particular hole location where we believe that is having problems for alignments. Once again, we can get a feel what kind of a misalignment. Now this is the type of quick results that we can see from design for manufacturing for the assembly. Okay, so once that is done, then we can take a look at some of the other areas that cause us to be concerned about this particular assembly. For example, interference of the design. So we see that a particular fastener on the top end does kind of run into a particular surface. That it shouldn't be that case. So in this case, that because it's underneath, we cannot see that, but design for manufacturing easily detect that for us. We also see that possibly misalignment of the holes, once again on a particular cover plate, that the fasteners are not properly aligned. And once again, you never would have able to see that just looking from the outside of the particular assembled assembly. So now let's take a look at the next one. This is what we call the fastener accessibility. So in this case, that when we have fasteners, we basically use the fastener to assemble these components together. But sometimes some of these fasteners might not be able to gain access to a particular area. In this case, let's take a look at one on the front end of that. Well, we see that a particular area, this particular fastener, even though in the assembly it looks like it's in the right place, but if you think about it, how can we get this particular fastener to be mounted to that particular area? They're just almost impossible. So let's take a look at that other one. It's what we call the fastener clearance. So basically is there enough clearance for fasteners to go into these particular female threads? The next one is what we call the engagement for the fasteners. Are these fasteners have proper engagements? A lot of companies are required to have certain engagement length of this to be able to properly tie the components down. Next thing what we want to do at the conclusion of this demonstration is let's take a look at some of the standard rules that comes with this design for manufacturing. So in this case, we can take a look at just one, for example, the hole depth to the hole diameter, the L over D ratio. For this particular setting in this company, that we set that to be, has to be minimum or cannot be greater than 4. So we can actually change that. So sometimes for other design or other factors and different area of consideration, that value could change. So each company can set up their own standards using the rule managers. Okay, so this is where they can come in and quickly make that modification and rerun their analysis and be able to get a different kind of results. And another thing that we can look at is what we call the help. This, along with this particular function, there are additional help documentations that user can access. In this case, that if we want to take a look at milling, what will be some of the results that we'll see at the bottom. So a lot of these are readily available for users to review why certain area for manufacturing is important. Certain features has to be included inside of your design. All these are available for inside the NX under the Checkmate. Thank you very much.